Hi, this is Janak Reddy Dubaka. One more topic for Re-Neet student, that is wave optics. So this is also very important one. We can expect at least two from this chapter. See here, in Young's double slit experiment, using monochromatic light of wavelength lambda, the intensity of light at a point on the screen where the path difference is lambda is k units. What is the intensity of light at a point where the path difference is lambda by 3? See, these are the problems I collected from my first book, that is Accelerated Learning Physics Handbook. See, this book I prepared 5 to 6 years back. This year in NEET 2026, this is the question given as it is in NEET 2026. See, that is the importance of this book. See here, in YDSE, intensity I naught is equal to 4 I naught cos square pi by 2. But here, a monochromatic light of wavelength lambda, the intensity of light at a point on the screen where the path difference is lambda is k units. So your phase difference is equal to 2 pi by lambda into path difference, that is equal to 2 pi by lambda. Path difference is lambda, this becomes 2 pi. But this intensity is given as k. So k is equal to 4 I naught cos square pi by 2, that is 2 pi by 2. Therefore, this becomes 2 gets cancelled, cos pi minus 1, cos square plus 1, therefore 4 I naught. Now, if the path difference is changes to lambda by 3, here I am taking I dash. First we have to find out the phase difference. In this case, pi is equal to 2 pi by lambda. Path difference is lambda by 3. Lambda gets cancelled. This becomes 2 pi by 3. In this case, I dash is equal to 4 I naught cos square pi by 2. Therefore, 2 pi by 3 by 2 pi by 3. This becomes 4 I naught into pi by 3 means cos 60. Cos 60 1 by 2. Cos square 1 by 4. This becomes I naught. But here 4 I naught is k. Therefore, from this I naught is equal to k by 4. Therefore, I dash is equal to intensity k by 4. Therefore, I dash is equal to k by 4. This is the intensity. Next one. In double slit experiment, the angular width of fringe is found to be 0.2 degrees and the screen placed 1 meter away. The wavelength of light used is 600 nanometers. What will be the angular width of fringe if the entire experimental apparatus is immersed in water? Take refractive index of water to be 4 by 3. See here, angular width theta is equal to lambda by d. When this experiment is immersed in liquid, in that case, angular width theta dash is equal to lambda becomes lambda by mu. Therefore, lambda by mu d. But here lambda by d is theta. Therefore, this becomes theta by mu. Therefore, theta dash is equal to initial angular width, that is 0.2 degrees by mu becomes 4 by 3. Therefore, this becomes 0.6 degrees by 4. Therefore, this becomes 0.15 degrees. This is the new angular width. Next one. A parallel beam of light of wavelength 500 nanometer. Therefore, here lambda is equal to 500 nanometer. Falls on a narrow slit and the resulting diffraction pattern is observed on the screen 1 meter away. Therefore, here capital D is equal to 1 meter. It is observed that the first minimum is at a distance of 2.5 millimeter. Therefore, first minimum y1 I am taking, that is equal to 2.55 millimeter from the center. Find the width of the slit. We have to find out A. Therefore, here For linear width of the minimum yn dark in diffraction, that is n lambda d by a. Therefore, here first minimum y1, therefore n into lambda d by a. Here we have to find out a, that becomes lambda d by y1. Therefore, here a is equal to, what is lambda given? 500 nanometers. 500 into 10 to the power of minus 9. D is given as 1 meter and y1 is 2.5 millimeter. 2.5 into 10 to the power of minus 3. This becomes 0.2 millimeter. See here. In Young's double slit experiment, the source is white light. One of the hole is covered by a red filter and another by blue filter. In this case, see, fringe pattern we can observe when the waves coming from the two slits should have or must have the same frequency. But here one is covered with red filter, another one is a blue filter. Therefore, the two waves having different wavelengths. Here we does not observe any diffraction pattern. Therefore, answer C, there shall be no interference fringes. See here. Consider the diffraction pattern for a small pinhole as the size of the hole is increased. See here, angular fringe width or fringe width of central maximum W is equal to lambda 2 lambda d by A. This is a linear width of central maximum diffraction pattern. W is equal to 2 lambda d by A. As the size of the pinhole increased, means A increased, therefore your width decreases. Therefore your size decreases. See, this as size decreases, the most of the light is concentrated in a small region, therefore intensity also increases. Here both the answers are correct. The intensity also increases and also size of the linear width of central maximum also increases. Next one. In Young's double slit experiment is first performed in air, then in medium other than air. It is found that eighth bright fringe in the medium lies where fifth dark fringe lies in air. The refractive index of the medium. So in YDSE, Yn bright is equal to n lambda d by d. But Yn dark is equal to 2n minus 1 into lambda d by 2d. But here it is found that eighth bright fringe in the medium, therefore here y8 bright in the medium means lambda becomes lambda by mu, therefore here n is 8 lambda d by mu d. But where fifth dark fringe lies in air, therefore fifth dark fringe means y5d is equal to n plus in place of n 5 into 10 minus 1 9 lambda d by 2d. These two are formed at same place, therefore y8 bright is equal to y5 dark. This becomes 8 lambda d by mu d, that is equal to 9 lambda d by 2d. From this lambda d cancel. Therefore here mu is equal to 16 by 9. This becomes mu is equal to 16 by 9. It is approximately 1.78. 1.78. This is a refractive index. Next one. Here two polarites P1, P2 are placed with their axes perpendicular to each other. Unpolarized light I0 is incident on P1. A third polarite P3 is kept in between P1 and P2 such that its axis makes an angle 45 degrees with that of P1. The intensity of transmitted light through P2 is, see here, this is P1, this is P2, these two are perpendicular. And third one, this is P3, this angle is given as theta. If the incident light is unpolarized, here is I0, this becomes I0 by 2. After passing through P2, the final intensity I is equal to I0 by 8 sine square 2 theta. If the incident light is unpolarized, if it is polarized, I0 by 4. Therefore, I is equal to I0 by 8 sine square, theta is given as 45, 45 into 2, 90, sine 91, this becomes I0 by 8. Therefore, answer B. Next one. The linear aperture whose width is 0.02 centimeter is placed immediately in front of lens of focal length 60 centimeter. The aperture is illuminated normally by a parallel beam of wavelength 5 into 10 to the power of minus 5 centimeter. The distance of fifth dark band of the diffraction pattern from the center of the screen. See here, linear width of which one? Distance of first dark band. See here, yn dark, that is equal to n lambda d by a. Here, first dark means n is equal to 1. Therefore, y1 dark is equal to lambda d by a. Therefore, y1 dark is equal to, what is lambda given? Lambda is 5 into 10 to the power of minus 5 centimeter. Therefore, into 10 to the power of minus 2 meters. And instead of d, we can write if you want to place a lens, then d you have to replace with f, lambda f by a. Therefore, focal length is given as 60 centimeter. This becomes 60 into 10 to the power of minus 2. A is the slit width, that is given as 0.02. 0.02 into 10 to the power of minus 2. And finally, the linear position of first dark becomes 0.15 into 10 to the power of minus 2 meters. This becomes 0.15 centimeter. Next one. In diffraction pattern, due to single slit of width A, the first minimum is observed at an angle 30 degrees when a light of wavelength 5000 angstroms is incident on the slit. The first second are secondary maximum. See, for minimum, A sin theta is equal to n lambda. Here, first minimum means n is equal to 1. Therefore, A sin 30 degrees equal to 1 into lambda. A by 2 is equal to lambda. Therefore, A is equal to 2 lambda. Then, first secondary maximum is observed right. For a maximum, A sin theta is equal to 2n plus 1 into lambda by 2a, or lambda by 2. Sorry, lambda by 2. This becomes sin theta is equal to, here first secondary maxima n1, 2 into 1 plus 1 lambda by 2a, that becomes 3 lambda by 2a, that is equal to 3 lambda, 2 into a means 2 lambda. Therefore, this becomes lambda, lambda cancel. Therefore, here this becomes 3 by 4. Therefore, theta is equal to sine inverse 3 by 4. This is the angular position of first secondary maximum. Next one. The intensity at the maximum in a YDSE is I naught. Actually, I is equal to 4 I naught cos square pi by 2. But 4 I naught is the maximum intensity, but here it is given as I naught. Therefore, I have to consider 4 I naught as I naught. The distance between two slits is 5 lambda, where lambda is wavelength of the light used in experiment. What will be the intensity in front of one of the slits on the screen placed at distance 10d? So here this one S2 and this distance is d, and the distance between the slits is d. In front of one of the slits, this distance is nothing but d by 2. Therefore, here path difference delta x is equal to dy by d. First, I have to find out path difference, after that phase difference, and after that I is equal to 4 I naught cos square pi by 2. So here d into, here y is given as d by 2. That is equal to d square by 2d. Here d is given as 5 lambda. Therefore, 5 lambda into 5 lambda by 2 into d is given as 10d. 10d. Therefore, delta x is equal to 5 lambda into 5 lambda by 20 into d is equal to 5 lambda. Therefore, here 5 lambda cancel. 5 4 times. This becomes lambda by 4. Then phase difference pi is equal to 2 pi by lambda into path difference, that is lambda by 4. Lambda cancel, that is equal to pi by 2. Then intensity I is equal to 4 I naught, but here it is given as I naught cos square pi by 2. Therefore, this becomes pi by 4. Therefore, I is equal to I naught cos pi by 4 means cos 45. Cos 45 1 by root 2. Cos square 45 1 by root 2 whole square 1 by 2. Therefore, I is equal to I naught by 2. Next one. In double slit experiment, the two slits are 1 millimeter apart. Means here small d is equal to 1 millimeter. And the screen is placed 1 meter away. Therefore, capital D is equal to 1 meter. A monochromatic light of wavelength. Therefore, lambda is equal to 500 nanometer. And what will be the width of each slit for obtaining 10 maxima of double slit within the central maximum of a single slit? Here we have to find out A. Therefore, for diffraction pattern, the central maximum width W is equal to 2 lambda d by A. Therefore, in that central maximum, there are 10 maxima of YDSE. Therefore, this W is equal to 10 beta. That is equal to 2 lambda d by A. Therefore, 10 beta means lambda d by d, that is equal to 2 lambda d by A. Therefore, here lambda d cancel. 2 5 times. Here I have to find out A. Therefore, A is equal to d by 5. And d is given as 1 millimeter. 1 by 5, that is 0.2 millimeters. 0.2 millimeter. Next one. In Young's double slit experiment, the resultant intensity at a point on the screen 75% of the maximum intensity of the bright fringe. then the phase difference between the two interfering rays at that point. So here resultant intensity I is equal to 4 I naught cos square pi by 2. But this intensity is given as 75% of maximum intensity. Therefore, maximum intensity 4 I naught, 75% means 75 by 100. That is 4 I naught cos square pi by 2. Therefore, here 4 I naught cancel. 25 3 are 25 4. Therefore, cos pi by 2 is equal to root 3 by 2. Therefore, this becomes root 3 by 2 means uh, cos theta root 3 by 2 cos 6 cos 30. Therefore, pi by 6. Therefore, 1 minute. Theta is equal to cos theta pi by 2 is equal to cos 30 pi by 6. Therefore, 3 times. Therefore, phase difference pi is equal to pi by 3 or 60 degrees. Next one. In Young's double slit experiment, the intensity at 2 points P1 and P2 on the screen are respectively I1 and I2. P1 is located at the center of the bright fringe and P2 is located at a distance equal to quarter of the fringe width from P1, then I1 by I2. See here, point P1 is at the center of the bright fringe. Therefore, for bright fringe, intensity is equal to 4 I naught. Next, we have to find out the intensity for P2. Therefore, this first we have to find out path difference. Delta x is equal to dy by d. That is d by d. Here y is located equal to quarter of the fringe. That is beta by 4. Therefore, d by d into beta means lambda d by d by 4. This becomes d cancel. This d cancel. Lambda by 4. Therefore, phase difference is equal to 2 pi by lambda into path difference. Lambda cancel. This becomes pi by 2. Now, intensity I2 is equal to 4 I naught cos square pi by 2. Therefore, 4 I naught cos square pi by 2, here pi by 4. This becomes I2 is equal to 4 I naught cos 45 1 by root 2, 1 by root 2 whole square 1 by 2. This becomes 2 I naught. But you have to find out I1 by I2. Therefore, I1 is equal to 4 I naught. I2 is 2 I naught. This becomes 2. Therefore, I1 by I2 is equal to 2. Next one. Two coherent point sources S1 and S2 are separated by a small distance d as shown. The fringes obtained on the screen will be. See here, when these two sources are joined by a line, if that line is perpendicular to the screen and the shape of the fringes are concentric circles. But whereas if the slits are like this, therefore if the line joining the slits is parallel to the screen, in that case the shape of the fringes are hyperbolic. It's a very, very important one. Next, in Young's double slit experiment, two slits act as a coherent sources of waves of equal amplitude A. and wavelength lambda. In another experiment with the same arrangement, two slits are made to act incoherent sources of waves of the same amplitude and wavelength. If the intensity at the middle point of the screen in the first case is I1 and in second case is I2, then I1 by I2. So here for coherent sources, here I1 at the center of the screen means a central maximum, I1 is equal to 4 I0. For incoherent sources, the resultant intensity I2 is equal to, here both the source slits have same width, therefore I0 plus I0, this becomes 2 I0. Here there is no phase difference. Generally we have to add I1, I0 plus I0. Therefore, I1 by I2 is equal to 4 I0 by 2 I0. This becomes 2 by 1. Next. When an unpolarized light of intensity I0 is incident on a polarizing sheet, the intensity of the light which does not get transmitted. So here, this is the polarizer. Here, this is a unpolarized light of intensity I0. After transmitting through this polarite, the intensity becomes I0 by 2. Therefore, from I0, I0 by 2 is transmitted. Therefore, remaining I0 by 2 is not transmitted. Therefore, not transmitted light intensity is I0 by 2. Transmitted light also I0 by 2. Next one. The maximum number of possible interference maxima for a slit separation equal to twice the wavelength in YDAC. See, for maximum intensity, path difference d sin theta is equal to n lambda. But here, the slit separation equal to twice the wavelength. Therefore, 2 lambda sin theta is equal to n lambda. This lambda gets cancelled. 2 sin theta is equal to n. For maximum value of sin theta is 1. Therefore, 2 is equal to n. That is equal to n is equal to 2. N is equal to 2 means this is central bright, first bright, second bright, and downwards also first bright, second bright. Therefore, maximum number of brights 1, 2, 3, 4, 5. Therefore, 5. Next one. In Young's double slit experiment, the distance between slits and the screen is 1 meter. Monochromatic light of 600 nanometer is being used. A person standing near the slits is looking at the fringe pattern. When the separation between the slits is varied, the interference pattern disappears for a particular distance. This one is D naught between the slits. If the angular resolution of the eye is 1 by 6 degrees, then the value of D naught is. Therefore, angular width theta is equal to lambda by D. Here I am taking D naught. Therefore, D naught is equal to lambda by theta. So, D naught is equal to what is lambda given? 600 nanometer, 10 to the power of minus 9. Theta is given as 1 by 60 degrees, but we have to convert into radians, 5 by 180. This becomes 2 millimeters. Next one. Angular width of central maximum in a single slit diffraction pattern is 60 degrees. So here angular width of central maximum, that is 2 theta. 2 theta is given as 60 degrees. Therefore, theta is equal to 30 degrees. Here theta is nothing but angular position of first minimum. The width of the slit is 1 micrometer. A is equal to 1 micrometer. The slit is illuminated by a monochromatic plane waves. If another slit of same width is made near it, Young's fringes can be observed on a screen placed at a distance 50 centimeter. Therefore, capital D is equal to 50 centimeter from the slits. If the observed fringe width is 1 centimeter, therefore beta is equal to 1 centimeter. What is the slit separation distance? What is the slit separation distance that we have to find out? D. Here, theta is the angular position of first minimum. Therefore, in diffraction, A sin theta is equal to n lambda. Therefore, A into theta is 30. Sin 30 degrees equal to 1 into lambda. Therefore, A by 2 is equal to lambda. Then, lambda is equal to 2A. This is lambda. But fringe width beta is equal to lambda d by d. That is equal, what is lambda here? 2A into d by d. Therefore, d is equal to 2ad by beta. 2 into a is given as 1 micrometer. 1 into 10 to the power of minus 6. Capital D is 50 centimeter. 50 into 10 to the power of minus 2 by beta is given as 1 centimeter. That is 1 into 10 to the power of minus 2. After simplification, we can get 25 into 10 to the power of minus 6 meter. This becomes 25 micrometer. 25 micrometer. Next one. Unpolarized light of intensity I is incident on a system of two polarizers, A followed by B. The intensity of emergent light is I by 2. If a third polarizer C is placed between A and B, the intensity of emergent light reduces to I by 3. The angle between the polarizers A and C. So here initially this is A. Here is the intensity I, therefore this becomes I by 2. Therefore, after passing through B also I by 2 means A is parallel to B. Here also I by 2. This is the condition given, means A and B are parallel to each other. Now, this is A. This one is B. Now, third polarizer C is placed. The angle between A and C is theta. Therefore, here is the intensity I. Therefore, this becomes I by 2. Here, I by 2 cos square theta. Here, I by 2 cos square theta into cos square theta. Therefore, this I dash I am taking. Therefore, I dash is equal to I by 2 cos to the power of 4 theta. But I dash is given as I by 3. I by 3 is equal to I by 2 cos to the power of 4 theta. I cancel. Therefore, cos to the power of 4 theta is equal to 2 by 3. Cos theta is equal to 2 by 3 whole to the power of 1 by 4. Therefore, theta is equal to cos inverse 2 by 3 whole to the power of 1 by 4. Therefore, this becomes cos inverse 2 by 3. Option A is correct. See here. Two coherent sources S1, S2 and a screen are arranged as shown in the figure. If the distance between the two coherent sources is n lambda and the distance of the screen from the near coherent sources is d, the distance of the first bright fringe on the screen from the point O. See here, Here is S1, S2. On screen O, the path difference between S1O and S2O is n lambda. When we are moving upwards from center of the screen, therefore here order of the fringes decreases. But whereas if the slits are like this, for example, here is nth order. When are moving upwards, order of the fringes increases. Right? Here is n, therefore this is n plus 1 th order. But here this is n, here is n minus 1. The next bride fringe is n minus 1. Therefore, order of the fringes decreases when the line joining the sources is perpendicular to the screen. When line joining the slits S1, S2 is parallel to the screen, in that case, order of the fringes increases. See here. For example, here is a point P. This distance I am taking D1 and this one is D2. This distance is X. Here I have to find out X. First, I have to find out D1. See, from this right angle triangle, D1 square is equal to, this is n lambda plus D whole square okay, first this is D1 I am taking. Okay, 1 minute. This is D1, this one is D2. Therefore, D1 square is equal to D square plus X square. Therefore, D1 is equal to D square plus X square whole to the power of 1 by 2. This becomes, I am taking D square common, 1 plus X square by D square whole to the power of 1 by 2. Here X is very much less than D. Therefore, this becomes D square 1 plus X square by 2D square. This becomes D square plus X square by 2D. So X square by 2. Here D square common means here it becomes D. Here also D comes out of the root. This is D. Here also D. This becomes D plus X square by 2D. Like that, we have to find out D2. Here D2 is equal to, but for D1, this length is D. For the both the triangles, this is same X. For S1O, this distance is D plus n lambda. See, in this equation, in place of D, I have to put D plus n lambda. Therefore, D2 is equal to D plus n lambda plus X square by 2 into D plus n lambda. Here, the path difference D2 minus D1, that is equal to, here is n lambda, here n minus 1 into lambda. N minus 1 into lambda. See, by substituting D1 and D2, finally we can get the answer. X is equal to square root of 2D by D plus n lambda by n. Therefore, this is X. This is the distance of the first bright fringe from the center point O. Next one. In Young's double slit experiment, the intensity of central bright fringe is I naught and the fringe width is beta. If a point is at a distance x from the central fringe, then intensity at that point. So here, general intensity I is equal to 4 I naught cos square pi by 2. But here, central fringe is given as I naught. Therefore, I is equal to I naught cos square pi by 2. But here, phase difference pi is equal to 2 pi by lambda into delta x. This becomes 2 pi by lambda delta x path difference dy by d. So pi is equal to 2 pi by lambda d into y is given as here x. Therefore x by d. X by d. Therefore pi is equal to here beta is equal to lambda d by d. From this d by d is equal to lambda by beta. D by d is equal to lambda by beta. This becomes 2 pi by lambda. This d by d is nothing but lambda by beta into x. This lambda gets cancelled. Now I is equal to I naught cos square pi by 2. Pi by 2 means this 2 gets cancelled. Therefore pi x by beta. Therefore this is also one another ready-made formula. Whenever intensity in terms of fringe width beta and the distance x from the center of the screen, this is I is equal to I naught cos square pi x by beta. Next one. Interference fringes were produced in Young's double slit experiment using a light of wavelength 6000 angstroms. When a transparent film of thickness 3 into 10 to the power of minus 3 centimeter was placed over one of the slits. If the fringe pattern is shifted by a distance equal to 20 fringe width, the refractive index of the material, here shift in terms of beta, shift is equal to mu minus 1 into t beta by lambda. Here shift is given as 20 fringe width, this means 20 beta. Mu minus 1 into t into beta by lambda. Here beta gets cancelled. Therefore mu minus 1 into t is equal to 20 lambda. Therefore here we have to find out the refractive index now. Therefore mu minus 1 is equal to 20 lambda by t. 20 into lambda is given as 6000 angstroms, that is 10 to the power of minus 10 by thickness is given as 3 into 10 to the power of minus 3 centimeter, that is 10 to the power of minus 2. Then after simplification we can get mu is equal to 1.4. Next. In Young's double slit experiment, two slits are made apart 3 millimeter. Means here small d is equal to 3 millimeter. Screen is placed at 50 centimeter. D is equal to 50 centimeter. The fringe width when a light of frequency n is equal to given as 5 into 10 to the power of 14. Then we have to find the fringe width. Fringe width beta is equal to lambda d by d. But lambda is not given. Here lambda is equal to c by n. N is frequency. Therefore beta is equal to c means velocity of light, that is 3 into 10 to the power of 8. D is given as 50 centimeter. 50 into 10 to the power of minus 2. And frequency is 5 into 10 to the power of 14. And D is given as 3 millimeter. 3 into 10 to the power of minus 2. After that we can get beta is equal to 10 to the power of 4 10 to the power of minus 4 meters. Next, in Young's double slit experiment, a monochromatic light of wavelength 600 nanometer is used. If the two slits are covered by a transparent sheets of thickness 0.132 millimeter and 0.1 millimeter of refractive index 1.5, the number of fringes that will shift due to introduce the sheets. So this is also very important. Number of fringes shifted when film glass slabs of different thickness. This becomes T1 minus T2 into mu by lambda. Therefore, n is equal to T1 is given as 0.132, 0.132 minus 0.1 millimeter. Therefore, 10 to the power of minus 3. Refractive index is given as 1.5 by wavelength is 600 nanometer. 600 into 10 to the power of minus 9. Therefore, here n we can get 80. Next, a beam of light is incident on a glass slab of refractive index 1.54 in a direction as shown in the figure. The reflected light is analyzed by a Polaroid prism on rotating the Polaroid. See here, this angle is 30, total 90. Therefore, this angle becomes 90 minus 33. This is 57 degrees. See here, mu is equal to tan I. Here, mu is equal to tan angle of incidence is 57 degrees. Therefore, mu is equal to what is tan 57? 1.54. In the problem also, mu is given as 1.54. Therefore, if the light is incident, arrow mark is incident with an angle of polarization, the reflected light is completely polarized. Therefore, here the reflected light is a plane polarized light. If that plane polarized light, if you place analyzer, when the analyzer is rotating, the intensity gradually decreases, becomes zero, after that increases. Therefore, here answer, the intensity gradually reduces to zero and then increases. Next, in Young's double slit experiment with light of wavelength lambda, separation of the slits is d and the distance of the screen is capital D, such that capital D greater than D and D greater than. If the fringe width is beta, the distance from point of the maximum intensity falls to half of the maximum intensity on either side. See here, I is equal to 4 I naught cos square pi by 2. Here intensity decreases to half of the maximum intensity, means 4 I naught by 2, that is 4 I naught cos square pi by 2. Therefore 4 I naught cancel. Therefore cos square pi by 2 is equal to 1 by 2. Then cos pi by 2 is equal to 1 by root 2. Cos theta 1 by 2 root 2 means theta 45. Therefore pi by 2 is equal to 45 degrees. Pi is equal to 90 degrees, that is pi by 2. Therefore, from this, path difference is equal to 2 pi by lambda, 2 pi by lambda into delta x. Here, 2 pi by lambda, delta x is equal to dy by d. But pi is pi by 2, that is equal to 2 pi by lambda into dy by d. From this, here pi gets cancelled. We have to find out if the fringe width is beta, then distance from point of maximum intensity falls to half. We have to find out y here. But here fringe width is beta. Therefore, we have to find out in terms of beta. Next one. Beta is equal to lambda d by d. From this, d by d is equal to lambda by beta. Now 1 by 2 is equal to 2 by lambda into this d by d is nothing but lambda by beta into y. Therefore, here this lambda gets cancelled. Therefore, y is equal to beta by 4. Therefore, at this distance from the center of the screen, intensity becomes or reduced to half of the maximum intensity. Next one. In Young's double slit experiment, the distance between the two identical slits is 6.1 times larger than the slit width. In Young's double slit experiment, the distance between the two slits is 6.1 times larger than the slit width. Means capital D is equal to 6.1 into A. Then number of intensity maxima observed within the central maximum of the single slit diffraction pattern. Therefore, the number of intensity maxima, that is n is equal to here W by beta. W is linear width of the central maximum diffraction pattern. Here beta is fringe width in YDSE. Therefore, W is equal to 2 lambda d by A, but beta is equal to lambda d by d. This becomes 2 lambda d by A, that is equal to d by lambda d. Here this lambda d gets cancelled. N is equal to 2 d by A, but d is equal to 6.1 A. Therefore 2 into 6.1 A by A gets cancelled. Therefore n is equal to 12.2. Therefore number of maximas n is equal to 12. Next one. In an experiment, single slit diffraction pattern, first minimum for red light coincides with the first maximum of some other wavelength. If the wavelength of red light is 6600 angstroms, then the wavelength of first maximum. See here, in an experiment, single slit first minimum of red light. Here yn dark is equal to n lambda d by A. Next one, yn bright is equal to 2n plus 1 into lambda d by 2A. Here first minimum, therefore y1 dark, that is equal to n is 1, lambda 1 I am taking, d by A, and coincides with the first maximum. First maximum means y1 bright is equal to n1, therefore 2 plus 1, 3 lambda d by 3 lambda means lambda 2 d by 2A. These two are coincides means y1 dark is equal to y1 bright. This becomes lambda 1 d by A, that is equal to 3 lambda 2 d by A. Therefore, here d by A cancel. Lambda 1 is equal to 3 lambda 2. We are to find out, here is another 2 is there. Therefore, 3 by 2. Here we have to find out lambda 2. Lambda 2 is equal to 2 lambda 1 by 3. Lambda 1 is the wavelength for red light, that is given as 6600 by 3. Therefore, this becomes lambda 2 is equal to 4400 angstroms. This is the wavelength for first bright.